Hello and welcome to the Edupedia World. In this tutorial, we'll study about memory management in Java. Well, actually I tried to find many references to make a PPT for this tutorial, but I think the best reference that you could find is on the Java docs. So let's study memory management in Java through Oracle docs that are present on the original website. Okay guys, so this is the docs.oracle.com. So these are the original documentation available by Oracle for Java. And in this, you can reach it by, typing this address, or even if you are not able to type it out or not remember, just you can actually search how memory is managed in Java, and this is the first result you usually get, understanding memory management in Oracle Docs. So you can just try out this one. Okay. Another important good link is this one, JVM memory management, that is general dev. But after comparing these two, I find this one is better. So let's go through this doc and see how memory is actually managed in Java. Well, memory management is the process of allocating new objects and removing unused objects to make space for those new object allocation. This section presents some basic memory management concepts. Explain basics about object allocation and garbage collection. Okay, so I'm not going to read each and every line from this page, but what I'm going to do is I'm going to, cover the important topic and explain you everything what this page is saying, because this is something I have already read, so I don't want to just stretch this video just to repeat the text whatever is written, and let's understand the topics. So the first topic is heap and nursery. So let's see what is it. Basically, as all of you know, Java has two types of, or has divided its memory in two types. One is stack and other is heap. Stack is usually used to keep objects which are temporary. For example, there's a thread stack, so all the threads are kept in a stack. There is a stack for local variables. There's a stack for the method calls. So these are things that are kept in stack, and all those objects that we need to keep on, at least for some duration, that we keep on heap. So let's see what is heap and what is nursery. Java object reside in an area called heap. Heap is created when JVM starts up and may increase or decrease in size when application runs. When the heap becomes full, the garbage is collected. Okay, during garbage collection, objects that are no longer used are cleared, thus making space for new objects. Note that JVM uses more memory than just heap. For example, like we have already know, Java methods are stored on stacks. Similarly, threads are also stored on stacks. Okay. Heap is sometimes divided into two areas. So, when we talk about heap being divided, so this is a implementation which depends on JVM to JVM. But yeah, if we talk about in a general sense, then we can say that heap is divided into two areas. One is called generation and other is called nursery. So it's called as young space and the old space. The nursery is a part of heap reserved for allocation of new objects. So whenever a new object is created, it is generally stored as a new object in nursery part. Okay. And when nursery becomes full, the garbage is collected by running a special young collection. Okay. So the garbage collection happens in nursery when all the objects that have lived long enough in nursery are promoted to the old space. So initially a new object goes into nursery. When this becomes old, it is promoted to old space, thus freeing up the nursery for more object allocation. So the garbage collector picks up and puts this into old space. So your nursery becomes clear for the new object allocation. When the old space becomes full, the garbage is collected here also, and the process is called old collection. So the reason behind nursery is that most of the objects are temporary and short-lived. So it might happen that your object need not be moved into a old space. The use of that object get finished before that. So that is the reason nursery is there, so that you can keep the newly created object, and if required it is promoted, if not required it is just cancelled or just got released from that. Okay, now let's study what is object allocation. Well, during object allocation, this talks about a particular JVM, that is JRocket JVM, but we are not going to concentrate on one particular JVM. Let's take it in a general sense how JVM behaves. So JVM does have small and large objects. The limit for when an object is considered large depends upon JVM version. That is the heap size, the garbage collection strategy, the platform used, okay, whether it's 2 or 128 KB. So we see all that in the documentation of your JVM, like which object it considered to be a small and which object it's considered to be large. It could be possible that for one JVM one object is small, but for other JVM that object could be large. Small objects are allocated in thread local areas, which is called TLA. Thread local areas are free chunks reserved from the heap and given to thread for exclusive use. The thread can then allocate the object in its TLA without synchronizing with the other thread. Okay. When TLA becomes full, the thread simply requests new TLA. The TLA are reserved from the nursery if such exists, otherwise they are reserved somewhere else in the heap. So when we talk about nursery, again it's not always compulsory that each and every JVM must have, but yeah, generally JVM do have nursery part. So thread uses thread local areas to keep the small objects. Then the large object that does not fit in TLA are allocated directly onto heap. When a nursery is used, the large objects are allocated directly into the old space. Fine. Now this was about a little bit about memory allocation. Let's see how garbage collection works. Well, garbage collection is a process of freeing space in the heap or the nursery for allocating new objects. This section describes garbage collection of a particular JVM. So, JVM, depending upon the JVM, garbage collection follow different strategy. For example, one strategy is mark and sweep model. Okay, so let's see what is mark and sweep model. Well, mark and sweep garbage collection model for performing garbage collection consists of two phases. One is mark phase and other is a sweep phase. During mark phase, all the objects that are ready to be garbage collected or that are reachable from Java threads and are still alive, but they can be are okay to be garbage collected are marked or identified. During the sweep phase, the heap is traversed to find out the gaps between the live project. These gaps are recorded in a free list and made available for new object allocation. So mark phase actually identifies and so that they can be marked for the garbage collection. And so basically the objects that are still alive are marked and rest of the objects which are not marked are considered for garbage. Okay. So all the objects that are considered as garbage are then actually garbage collected. Then the sweep phase actually travels to find the gap between the live objects. So if there are gaps, so all these gaps are marked as free list so that new allocation can be done in these memory gaps. Fine. So this is called a two-phase mechanism, and we have two kind of mark and sweep. One is concurrent and other is parallel. Well, let's not go into that detail of studying what is concurrent and what parallel, but as the name suggests, concurrent happens concurrently. So concurrently means two or more tasks happen at the same time, whereas parallel actually divides its task into subtasks to continue. Okay. So just skipping the details of it, let's go to a generation garbage collection. Okay, so the nursery when it exists is garbage collected with special garbage collection called young collection. So let's see how garbage is collected from nursery. The garbage collection strategy which uses a nursery is called generational garbage collection strategy or simply generational garbage collection. The young collector used in JRocket JVM identifies and promotes all live objects in nursery that are outside and keep the area to old space. This work is done in parallel using all available CPUs. Java thread are paused during the entire young collection. Dynamic and static garbage collection modes. So let's see them. By default, the dynamic garbage collection mode that automatically selects garbage collection strategy to use, aiming at optimizing the application throughput. You can choose between two or other dynamic garbage collection modes or strategy. And what are the different modes that are available for garbage collection? First mode is throughput, which optimize the garbage collector for maximum application throughput. Okay, this is a default mode. Then we have pause time, which optimize the garbage collector for shorter or even pause time. So whenever there is any pause time, the garbage collection works at that time. Then is deterministic, which optimize the garbage collector for very short and deterministic pause time. This mode is only available as a part of Oracle JRocket Real-Time. Okay, so this is part of a particular JVM. Major static strategies are single par, which is single generational parallel garbage collector, same as parallel. Then we have Jenipar, which is two generational. Then we have single con, which is single generational, mostly concurrent garbage collector. Then Genicon, which is two generational, mostly concurrent garbage collector. Okay, then there is a concept called compaction. Let's study the introduction to this topic. We will not go in real detail, but let's see what it says. The objects that are allocated next to each other will not necessarily become unreachable at the same time. This means that the heap may become fragmented after garbage collection. So it might happen there is a continuous, memory allocation from 1 to 10, but the garbage collected memory is 2, then 5, then 7, then maybe 9. So it might not be, consecutive garbage collection, but your heap might contain some fragment once the free spaces are collected. Okay, now these free spaces are smaller than minimum thread local area. So these spaces may be, too small for a object to be there, but that doesn't mean we should waste these free spaces. Then what we should do is we should actually try to reduce the fragmentation. So this thing is done as a part of compaction. So this is a, concept of compaction to it is actually performed during the sweep phase while Java threads are paused. And there are two types of compaction, external and internal. I'll not go into the details of how it is done, but yeah, it was important to know at least what is compaction. So this was object allocation and memory management from docs. I would also like to cover some of the things from this tutorial. This is another important, what should I say, interesting tutorial, and it does contain a memory model of Java in detail, and it's very well explained over here. So it says the Java memory model specifies how Java virtual machine works with computer memory. The Java virtual machine is a model of a whole computer, so this model naturally includes memory. Okay, and always it's important to understand how it is allocated. Now coming straight to the point, this is a diagram which shows how it's divided. It's divided, the stack is divided into thread stack and the heap. Fine. So each thread running in Java will have its own thread and there is a common heap memory. The thread stacks contain information about what method the thread has called to reach the current point of execution. Okay, we can also call this as call stack. The thread stack also contain all the local variables for each method being executed. The local variables created by the threads are invisible to other threads. Okay, because they are into different stacks. All local variables of primitive type, for example, boolean, byte, short, char, int, long, float, double, are fully stored onto thread stack and thus not visible to other threads. One thread may pass a copy of primitive variable to another thread, but they cannot share primitive variable. Heap contains all the objects created in your Java application regardless of what thread created the object. This includes object version of primitive types. So when we talk about wrapper classes, the wrapper classes are included in heap. Okay. It doesn't matter if an object was created and assigned to a local variable or created as a member variable, the object is always still stored in heap. Here is a diagram we can see in the this thread we are having which all methods are called and what are their local variables. Similar thing for this thread. And all the objects are stored in the heap. The local variable may be of a primitive type, in which case it is totally kept on thread stack. The local variable may also be a reference to object. In that case, the reference is stored on a thread stack, but the object itself is stored on a heap. Fine. So when you do create an object, you also create a reference. So the reference is stored on a stack, but the object is stored on a heap. The object may contain method that these methods may contain local variables. The local variables are stored in a thread stack. Even if the object the method belongs to is stored on heap. The object member variables are stored on heap along with object itself. It is true both when member variables is of primitive type and if it is reference. If it is inside an object, it will still be stored in a heap. Static class variables are also stored on heap along with the class definition. Fine. Objects on heap can be accessed by all the threads that have reference to that object. When a thread has access to an object, it can also get access to object's member variable. If two threads call a method on the same object at same time, they will both have access to object's member variable. But each thread will have its own copy of local variable. So this is how these two threads are trying to access these objects. For the local variable, they will have their own copy, but for the shared object, they will share the copy. Okay, two threads have the set of local variables. One of a local variable point to shared object on heap and two threads each have different reference to the same object. Their references are local variable and thus stored in each thread stack. The two different references point of same object are on heap though. I'm not going into detail because this example is a part of thread, so just skipping it out. Now let's go to hardware memory architecture, how hardware memory is managed in Java. Well, the modern hardware memory architecture is somewhat different from internal JVM, and it is important to understand the hardware memory architecture too, to understand how a JVM works with. Okay, so in this section you can see over here we are having CPU and CPU registers. Then we have CPU cache memory and then we have the main memory. So this is how computer memory is. And let's see how actually JVM memory works with it. So here is a diagram. You see the JVM memory. The thread stacks can actually access the CPU register and they can also access the CPU cache memory, so with the RAM. Similarly, heap can also take the things from any of the memory. So when objects and variables can be stored in various different memories area in computer, there could be certain problems that occur. So these problems are visibility of thread updates to shared variables and race conditions. So we have already seen how we can overcome these two things whenever the reading from the memory happens. Visibility can be taken care by volatile variable, and to minimize the race condition we have different kind of solution that we have already covered while covering the concurrency control in Java. Okay guys, so this was about the memory management in Java. We have covered how memory is managed in Java, the stack, heap, nursery, how garbage collection works on that. Then we have also seen that how your computer's internal memory acts and how they actually combine with the JVM and what all problems can occur. And in the past we have seen how to overcome those problems. So this was about memory management. Thank you guys. Let's meet in the next tutorial. Thank you.